Thank you. Hello everybody. My name is Matti Kokkonen and I come from Statistics Finland. And I've done this work with my colleague Tuuli Pihlajmaa. I work as a senior statistician with transport statistics normally. And Tuuli works as a application specialist. And we chose this challenge because we wanted to do a data analysis challenge, and our original aim was to use machine learning algorithms for classifying the region. And it's also fun to work with some other data that you're not usually working with. And we were going to use supervised machine learning to classify the coastline grid cells, but we struggled to find suitable data sets for training. So in our solution, we combine traditional geoprocessing, and we have calculated some distance matrices. And we have also used unsupervised learning to classify the coastline into 5 different categories. And this is a bit simpler solution than the previous one. We have only used 4 different data sets from Helcom to cover the basic needs of a holidayer. So we got the Helcom 1 kilometer by 1 kilometer Baltic Sea grid. Then we have the urban land use layer and baiting sites and sandbanks. And then we have the coastline from Eurostat that we use to get the grid cells that are closest to the coastline. And our traveler is quite simple. He or she just wants to know if it's close to the city or not, or urban areas or not, or if there is a baiting site or a sandbank. But this model can easily be expanded, so not to worry. And methods and tools that we have used. We used QGIS for separating the coastline grids and other spatial information. And then we have added the data, the cells with SAS, and we also did the distance matrix calculation with SAS. I like to calculate quite a lot on my laptop, so that's why. And then we did clustering with k-means method in scikit-learn. It's a Python package readily or freely available for everyone. And we did labeling by hand, and then we have used Esri products for presenting the results. So we have done a story map, and then we have also done some maps in ArcMap. And how did we define the coastline? First, we detected, or we wanted to detect the cells that were on the coastline. So first we had to download the coastline layer from Eurostat, and then it was dissolved into one feature in QGIS, and we added a 1 kilometer buffer of 1 kilometer radius on it, and then we used that to extract the cells from the whole Baltic Sea grid with that buffer. So as you can see, this is the whole, or a part of the sea, Baltic Sea, and then we have cut with the coastline. So we get like a uniform layer just on the coast that we can populate then with data. So we had our 2 or 3 different layers. We had the urban land use layer, and we divided that into 2 different categories. I think it has 13 categories in the Helcom dataset. So one is category suitable for holidaying. So it includes dwellings, recreational areas, and the green urban areas. And then the yellow one, we consider it as unsuitable holidaying. So it includes industrial areas, airports, ports, and so on. And then we actually turn this layer, or this urban land use layer, to points. So we could calculate the distances between the centroids of the grid cells to the urban land use layer, and then we could choose the closest feature, closest point from the urban land use layer, and that's how we could determine that at what kind of value each grid cell gets. And for performance reasons, we used the 10 kilometer upper limit. And if there was no match on the urban land use layer, we considered the closest area on land to be unpopulated. And this is an example of the data that goes into the clustering process. We have the urban land use class, which is 1 or 0. 1 is for populated cells, which are suitable for holidaying, and 0 is remote or unpopulated areas. And there is also the distance to it. And then there was the 10 kilometer upper limit. And then there is bathing sites, which consist of sandbanks and bathing sites from Helcom. So the sandbank was a raster layer, but we turned that into vectors as well. And then we gave the distance 10 kilometers if there wasn't any bathing site, or if it was unpopulated cell, or if it got the value. And those grid cells that considered or got the value unsuitable for holidaying, we left those out from the clustering process, because you have to label them yourself. It doesn't, the unsupervised learning doesn't really give you any values. You have to look at the results and then you have to label them yourself. So it's easier if you have clear classes. So clustering and results of clustering. We used unsupervised machine learning, k-means algorithm, which was in the scikit-learn package, as I said. And we used default settings. We only adjusted the number of clusters. And I don't know how many of you are familiar with k-means or like clustering unsupervised learning anyway, but in k-means it will allocate every data point to the nearest cluster while keeping the centroids as small as possible. And here you can see the centroids. Like one was it got value of 1 if it was close to the urban area, and here you can see it has a small distance and the value of the centroid is 1. And same here, and then if you had the beach, it gets value 1, or the centroid gets value 1 and the distance is low, and vice versa. If it's not close to the beach, it will get smaller, or close to the 0, and distance will get very high. So it will try to match every grid cell to its own cluster or own category, basically. And what we had 59,431 coastal cells in total, and most of those cells fell into category of having beach and urban area nearby. And 7,177 coastal cells were deemed not suitable for holidaying. And if you look at the results country-wise, you can see Denmark, Germany, Poland, Latvia and Lithuania. Those countries have most of the grids in category beach nearby and urban area nearby. Estonia seems to have most remote beaches, so no urban area nearby. And in Finland you have, well, the biggest category is no urban areas nearby and no beach. Well, that's expected, I guess. And if you look at the Russia, it's actually because there was no values or classification in urban areas or in the urban land use layer. So that's why almost everything falls into the last category, or the no urban areas nearby, no beach. And those values that are here, I think these are in or close to the border. So that's why they get values. Otherwise it should be basically be 0, I guess. And if you look at it on the map, you get, I guess, pretty much same results as guys from KTH. This is Helsinki area, as you can see. So there are urban areas with beaches nearby here in the center. And then there are also areas which are not suitable for holidaying. I guess there are some port areas and industrial areas. And if you go further away, well, you get the areas where there is no urban areas nearby. And we have prepared a use case on PowerPoint. So I would like to spend a holiday by the sea, but I don't know where to go. But I have a few preferences. Since I'm a Finn, I would like to get away from people. I would like to have a beach nearby. And I also like to travel eco-friendly, preferably by bike. And starting point of my journey is Kalasatama area in Helsinki. And so I choose areas which have no urban areas nearby, but I want to have beach. And if I use our service or map, I get two alternatives which are within biking distance to Helsinki. Well, there is an area in there, but you cannot really bike there because it's on the sea, it's an island. But one is in Vetlaks in Raasepori, it's some 140 kilometers away, and the other one is in Kappel in Loviisa, so it's more reachable. So I think I will choose that one. And if you look at what can I see there, well, luckily they have the Pernaja Bay and Pernaja Archipelago Marine Protected Area there. And so I should be able to see some animals, seals, some birds like velvet scoter, long-tailed ducks, mew, and so on. They should also have coastal lagoons, reefs, I guess good for scuba diving, Baltic Esker Islands, narrow inlets, so I think it should be quite beautiful. And I also checked if they have any accommodation, even though it's remote. This is from Airbnb, so there should be a wide variety of cottages available. So I think this is where I'm heading. And if you want to try our results or look at our results yourselves, we have prepared a story map. The link is in the presentation, and if you want to contact us, there is our contact information. So I guess if there is no questions, I will take my bike and go. Thank you.
I think it would be interesting to see the story map.
Yeah.
We have some time.
Yeah.
I have been told that there is some rain in Holland.
Yeah.
The first look at this. That's, yeah.
Yeah. Well, the story map basically tells the same story that I told here, but I guess it doesn't really matter. We can look at the maps. Maps. Right. It even has the same picture, but it's apparently not downloading. Well, this is what we started. So we had the grid cells, but there is no data in them. So this is the same presentation. We can take another area for look at. We can take Gotland, for example.
Can you choose the starting location yourself?
I guess it's questions of Esri, I guess. But I guess when you do the story map, when you're preparing it, I guess you can choose it like on the map. But this is not an application. This is just a story map. So yeah, presentation. Yeah. So here are the same preferences. And then we tell the same, that we have the layers. And we use the k-means clustering. And here you can see the results of the clustering. So we have covered the whole coastline here. And maybe we can look the whole region. Is it, in our analysis, is it unsuitable for holiday? Well, if you want to go remote, there are like places where there is no urban areas nearby, and there should be some beaches. Well, can't remember the colors, but yeah, there are some beaches.
But this is great, so you can browse the information and there for yourself.
Yeah, you can use the maps like independently, but basically this was just for the judges and for the people to look at afterwards. But this has the same information, so we use the routing application which is built in this ArcGIS maps or ArcMaps. ArcMap Online, I guess it's called. And yeah, the same results. We go to Kappöle and what we can see. So yeah. Yep.
Great.
Oh, thank you.
So if I want to select another origin and destination,
yeah,
I ask you.
Yeah. Well, it's not an application. It's just a map. But of course, the idea is it's a data analysis.
Yeah, okay.
But of course, the idea is that you have your own preferences, and you choose your starting point. And since we want to be eco-friendly, I guess we should also promote going to the closest suitable place.
I have just one question.
Yeah.
Which things did you find most difficult doing this project?
Well, maybe getting the basic idea. I guess the data processing, that's what I do, so it wasn't really that difficult. And maybe choosing the variables for the classification. Now when I thought about it yesterday, we could have added more. We could have used guys in KTH. We could have layers that filter out the places. So it could be like further developed, of course, as every product. But that's like since we fixated on the idea of using some kind of machine learning algorithm, I guess that's like steered us to this direction. So I guess you could say that we chose the method first and then we tried to work with it. Yep.
Did you try different combinations of parameters?
Yeah, we did. But some of the layers have like quite big areas which have the same value. So it kind of overpowers the model, so you don't really get the variation on the areas. So yeah, we did try to, but we could have done like several different clusterings on different subjects like litter or spills. That could have been one cluster, and then we could have played with the layers. But now we only have this single layer, single clustering, single analysis. But of course you can further develop, as I said. Yep.
Couple of questions on the data processing. So first, can you elaborate more on the role of SAS software?
Yeah.
Is that something you could do also with the GIS, or I mean?
Not really.
The second question is, can you elaborate more also on how you chose the areas that were not suitable for holidays? So how did you?
First on the SAS, I think it has one GIS feature. It can calculate distances if you have it in right format. So if it's in VGS84, you can calculate distances between 2 points. But of course you can do a distance matrix if you don't care about that, you can do a distance matrix with any program. If you have just like point data, which we had, since we extracted the points from the urban land use layer and also from the sandbanks and the bathing sites, they were all already in point format. And the second question was
how you selected the area that were not suitable at all.
Yeah, well, we used the urban land use layer, and if it had a closest area on the grid cell to the urban areas that was closest to the respective grid cell was classified as a industrial area or port or mine or whatever. Yeah, we use those classifications. Yeah, but the classes actually they are not present in the metadata in Helcom. So we had to find those. The labels.
Is that a Helcom layer, the urban land
Yeah,
use?
yeah.
Is it really?
Yeah.
Welcome.
Yeah, it's in the Baltic Sea region. It's not originally, of course, but yeah,
it's not originally.
Yeah.
I'm wondering if it's from.
Yeah, I think it comes from yeah.
Exactly, that must be,
Yeah. But you could add the labels. We make it much easier. But no worry, I found them. So
Okay.
no worry, not to worry. Yep.
How much did your processing took time, and especially extracting these pictures and reprocessing the data?
Well, luckily it's 1 kilometer by 1 kilometer cells, so not that much. I think it was 59,000 cells, and then we used a 10 kilometer upper limit. I would say it maybe took like, I don't know, 20 to 30 minutes to find the closest feature on a laptop, so not that much. No. Yeah.
What did you learn yourself?
Sorry?
In this challenge, what did you learn yourself? What was what?
Well, I think it's the same thing that Bart said yesterday. That spatial. I can't remember the exact thing that he said, but wasn't it something like spatial data is not special with asterisks? So you can take out you can leave the spatial component to wait, and then you can do everything with the other data. So you just need to link the data sets that you have, and then you can do like normal data processing, and then you can give it back to the locations. So I guess like if you would have some training data, we could like expand this or use this in any application or unsupervised learning. Why not? So I guess I knew it already, but yeah.
Because all these algorithms, all this technology, where you knew all this, right? Or did you learn anything new?
Well, I haven't used unsupervised learning before. I only have used supervised, so
Okay.
yeah, something new. I guess you always learn something new. Yeah.
Okay, if there are no other questions, thank you.
Thank you.